What I'm going to do right now is give you a broad understanding of the factors which are driving change in the refrigeration air conditioning industry. So I've characterized it in this way: new international agreements driving regulation worldwide, new technology, all dimensions, not just mechanical, but throughout the HVACR field, new standards, regs, training, commercialized, just a whole bunch of change, and impacting every sector in HVACR. The things that I'd really like you to take away from this particular talk is that the industry on a global basis will add 56 to 90% to global warming by 2050 if we don't stop using HFC refrigerants. That's additional to carbon at 450 ppm. We're at a cliff edge with carbon. HFCs take us way over it. Therefore, the international agreements are driven to what's called the HFC phase down. It should be the HFC phase out. Nonetheless, if you want to learn about it and track that topic, that's the phrase to use. In Australia, cost savings in the order of 10 billion per annum from energy efficiency in the industry. And because we're talking about a fundamental change in the refrigerants, future-proofing your investment in HVACR technology is about getting the refrigerant right. I'll just touch on safety from time to time, but this is an important takeaway. Safety in this industry is misrepresented in the extreme. The truth is that all refrigerants need to be handled with care by trained professionals. It's not a distinguishing factor by refrigerants. They're all dangerous. Competent people can make them safe, and the risk of an incident is vanishingly low. And we're debating this matter nationally and globally because we have a new standard on the table. Okay, so let me describe the industry. It impacts everyone everywhere, basically every industry. So 53 million installations worth about $100 billion in Australia. The industry consumes in excess, in fact, of 22% of the electricity that we generate as a country. It generates, in my view, in fact, over 14% of national greenhouse gas emissions. I'll explain how I get to those numbers. And it's a highly decentralized industry, right? 70,000 tradesmen, 20,000 firms. How do you coordinate all of that? But that's the scope of the industry. Here's a breakdown by major sector. And so you get a sense of the volume of installations. Of course, domestic, small units and motor vehicle air conditioning is big by number, but things like commercial chillers and grocery store installations are big by energy consumption and direct emissions. So we'll talk about that. Where does the electricity go? Today, it's probably more like 60% going into air conditioning, all kinds, and 24% into the cold chain, which, by the way, just isn't about food. It's all kinds of things in the cold chain, but food's the one we think about. By building, in a sense, when I think about this chart, it's everywhere. There isn't a building discriminator. So to understand the role of refrigerants, you need to understand that when you invest in a plant, or you conduct a retrofit to align with the transition to low emissions, you're choosing indirect emissions, energy efficiency, and you're choosing direct emissions. So in Australia, 10% of national emissions are indirect in the HVACR industry, and about 4% is direct, and frankly, I think that number is higher, but I won't debate it. So let's examine indirect emissions. The fact is that natural refrigerants are unarguably more energy efficient, better at heat transfer than synthetic refrigerants. That's just a physical fact. You can screw it up, right? You can have a good refrigerant and bad mechanical engineering, and you'll get low performance. But that's not the point. Use that natural refrigerants properly with modern high-efficiency technology, and you will deliver, by definition, a greater energy efficiency. So the range is extreme, depending on the application. So motor vehicles, you might be in the order of 4 or 5% energy efficiency improvement, but in commercial refrigeration, industrial refrigeration, in the order of 40%. And then you add to that other ways of delivering energy efficiency, like better managing your heat load, better managing your control systems, and you can get up to 60 to 80% energy efficiency improvement. That is a concept I'll talk about later, but it's a very important idea. Direct emissions. All refrigeration air conditioning systems leak refrigerants. They're mechanically intense, they shake, they break, they leak. This can be managed, but it's pretty much impossible to avoid direct emissions entirely. Not the least of the reasons being that we don't enforce the prohibition. So it's been illegal since 1995, one organization prosecuted. What's the message to the rest of the industry? Don't bother. Particularly when it's in the interest of the technician or the service company to put more in a recharge situation, therefore he's billing the client and making more money. Of course, as I say, low maintenance is an issue. And by the way, direct emissions, that big hit in terms of increase, is principally the growth of HVACR in the developing world. But that doesn't let us off the hook for reasons that I'll explain. So why are we in this crazy situation? Natural's better in every way. I'll explain in more detail. And yet, right now, synthetics dominate the industry. Prior to 1940, naturals were the refrigerant of choice, in fact, the only one. Our engineering wasn't up to the task from a safety point of view, so we invented CFCs, problematic, Montreal Protocol. We invent HCFCs, which are slightly lower ozone depletion, both, by the way, high GWP, and we're very close to getting rid of them, and we move on to HFCs and then the Kyoto Protocol and so on. The future, and by the way, this chart I stole from Danfoss, and Danfoss says the future is sustainable or low GWP refrigerants. The alphabet soup of the industry is tough to follow. The naturals, ammonia, CO2, hydrocarbons, effectively no GWP, not ozone depleting, far more energy efficient, and lower cost. So where are we right now in terms of international agreements? So it's changing, but right now the Montreal Protocol is just about eliminating the use of ozone depleting refrigerants. That will change. The Kyoto Protocol is about counting the volume of emissions. But notice already a gap. The Kyoto Protocol does not count HFCs and CFCs even though they're high GWP. This makes no sense, but that's the reality. And that's why our national inventory, in part, understates the presence. Worse, the real impact of the industry is defined by these factors. The average HFC has an atmospheric life of 21 years. Its 20-year GWP is twice its 100-year GWP. So the Kyoto Protocol measures, and almost all of the work done in this field talks about the global warming impact of HFCs based on their 100-year GWP. This makes no sense. R32 is a refrigerant that's being rolled out, promulgated worldwide, on the basis that it's a moderate GWP HFC. 675 on 100 years, 2,330 on 20 years. So the result of those factors is that level of emissions attributed to synthetic refrigerants is understated dramatically. The science that underpins the move to the amendment of the Montreal Protocol says that synthetic refrigerants will add 28 to 45% by 2050. But if we did that based on 20-year GWPs, that'd be 56 to 90%, and that's additional to carbon. We're at the edge of carbon. And by the way, there's a lot of miscommunication on this, and it's bloody difficult to get it absolutely clear. I think you'll see this examined continuously. From a cost point of view, it's inevitable we're going to have carbon pricing at some point in the future because it makes so much sense. when we have carbon pricing at 20-year GWPs, the cost of synthetic refrigerants will go through the roof. Okay, where are we now in terms of the amendment? So right now, the Montreal Protocol says we'll phase out, ban the use of HCFCs, CFCs by 2020 in the developing world. Australia, it's already there. We're down to the last. Our quota right now, I think, is something like 2.5% of the baseline. So if you've got a machine using R22, you want to think about changing that soon because the cost of R22 is going to go through the roof. Developing countries, not till 2030. It's an issue. But the amendment will call for the Montreal Protocol to be used as the basis for dramatic reductions in the use of HFCs. So these are the propositions that are in front of the parties to the Montreal Protocol. The yellow line is existing legislation in Europe. Europe is moving ahead. So where are we? The EU legislation is in place, 79% phase down by 2030. The G20, Climate and Clean Air Coalition support this. It's highly likely, therefore, that by the end of this year, by 2017, the Montreal Protocol will be amended in the way that I've mentioned. OEMs are going to move ahead of these international agreements because it's obvious, because we have serious competitive pressures between naturals and synthetics, and that's going to drive both sides to change. And where's Australia? The foundation legislation in this field is the Ozone Protection Synthetic Greenhouse Gases Management Act. It's been under review for 3 years. The industry, in response to the papers put by DOE, said we must have nationally consistent legislation that deals with all refrigerants. The papers put by DOE said the opposite of that. So we've got some rather fundamental issues to review, and it's not clear, given the risk of an election, that this is going to be dealt with anytime soon. As I say, OEMs are moving ahead. HFCs in Australia basically unavailable in the very near future. The phase down of HFCs is imminent, and there will be a major shift to low GWP refrigerants. So I can't give one of these talks without quoting Obama. Take his wonderful words in that regard. Canada and the US have signed an agreement specifically calling for HFC phase down, but so have many other countries. Let me see if I got them there. China and India, those agreements are in place. You've got basically the vast majority of the world, the vast majority of the parties to the Montreal Protocol agree we need an HFC phase down. One day we'll get them to say it properly. What's happening globally? The Climate and Clean Air Coalition has, this is 49 countries, 53 industry partners, one of which is the Australian Refrigeration Association, calling for the reduced presence of short-lived climate pollutants, including the HFC initiative. This is a significant body shifting the difference. And by the way, the synthetics industry and the natural refrigerants industry, both well represented and both saying, let's get on with this, let's get out of high GWP HFCs. The Consumer Goods Forum, you'll hear further from Ignacio on this very important topic. But big companies, huge global revenue, unequivocally committed to the use of natural refrigerants. For these companies, refrigeration is mission critical, and it's very clear to them that naturals are the future. You can find all of these organizations on my website, which gives you a long list of sources on the topic of the use of natural refrigerants. But as we move to natural refrigerants, we have to understand that low GWP refrigerants have different engineering and service requirements. Whether it's a retrofit or a brand new unit, it's going to be different equipment. And so, by the way, that means most of the equipment worldwide over the next 15 to 20 years is going to get traded out, either by way of retrofit or by replacement. And with that, a whole series of regulatory standards, training, and so on requirements, and a major commercialization exercise. Because when you launch a new piece of equipment, you better have it independently validated, or it's not going to fly. Well, you'll get a sense of the amount that's going on. I want to go back to the matter of safety because it really annoys me. Here's the situation. The frequency of incidents is vanishingly low. You talk to the work health and safety people at the state level, they don't even collect the data because it almost never happens. Worse than that, though, as a result, it's not known how significant an issue is this in the risk management sense, and worse than that, we don't have decent independent research on the impact on technicians when they inhale synthetic refrigerants. My intuition, and the intuition of others, is it's not a good thing. That's another story. An example of a standard that is on the table is the classification of moderate and low GWP refrigerants as A2L. A, non-toxic, L, low flammability. Both untrue. When you burn R32, you get hydrogen fluoride and carbonyl halides, which are among the most lethal chemicals on the planet. And you get that at the rate of 20 to 30% of the mass of the refrigerant. This topic does not appear in the standards. Flammability. If you read the MSDS for R32, it says it's extremely flammable. If you read the standards, it says low flammability. Please help. Which of these is right? The standards are a problem because the standards development process is vulnerable and fundamentally flawed. The truth is, safety in HVACR is about one thing: trained engineers and technicians. That's everybody, including specifiers and facilitators. And I reckon a very conservative number for that is 100,000 people in Australia alone. Huge educational requirement, far more than anything I've ever seen in my career. And right now, we have discussion being led by the federal government, which is fundamentally undermining TAFE. And yet, if you look at TAFE schools across the country, they have wonderful facilities with wonderful teachers. There's got to be a better way to fix them than simply competing with private RTOs. So my point is, the industry has the opportunity to reduce the energy cost by 60%, or around $8 billion, reduce greenhouse gas emissions by 50%. That's 7% of national emissions. Those opportunities are commercially warranted by the energy efficiency principally, but there's a huge amount of work to do. Despite that situation, because of the nature of the competitive confrontation, you can expect a high degree of obfuscation going forward. It's the nature of the industry. When you research it, when you study it, triple check everything. Where does that information come from? How's it been validated? Does it make sense? And if you don't do those checks, you won't get it right. What is transition in Australia? Driven by energy efficiency, eliminating direct emissions by using very low GWP materials. Australia should be a leader. There is high growth for those companies that engage and take this opportunity. It will influence our national competitiveness. It is an export development opportunity because we have great leadership in this field, and you'll hear them today. And there's a major, we could avoid about $1 billion in imports by avoiding synthetics. Almost as importantly is guiding and working with the third world to facilitate and accelerate their phase out. I stole this from the Environmental Investigation Agency. The situation today is we have an industry dominated by synthetic refrigerants. It's hard to drain that swamp because of the dominance. The sensible thing to do when you're looking at an HVACR plant is future-proof. Choose a refrigerant that is not going to get phased out and is not toxic. So I'm going to talk this afternoon about the factors that determine transition to energy efficiency in the HVACR, but in brief, they are those. As I said earlier, integrated energy efficiency is absolutely fundamental. It's not enough to get the mechanical engineering right if the windows are open or the insulation is substandard or the ducting is substandard or low quality. And energy management is critical. So this is a quick listing of all of the dimensions and sectors that need to be addressed. Innovation in every single dimension of the industry. And therefore, the huge requirement for research, training, and education of the industry at large.